Hello there, and in this video lecture we are trying to learn what is the types of supports and support reactions. It is must have the knowledge on the constraints. So then because of these supports we are trying to arrest the motion of your body in a specific direction so that we can get exactly what we want that function from we can get from that object. That means we design a specific object for the specific function to perform it, so then we can get it that part. So then what type of supports and what type of reactions are going to be generating? This is going to be related to the previous video lectures, that is the constraints. So in this case, the types of supports and support reactions. So first I have taken the frictionless support. In this case, the reaction acts normally to the surface at the point of contact as shown in figure. So then I am going to be representing here the graphically. So first I have taken a horizontal surface. That is going to be assuming that this is the frictionless support I have taken. So that is A. And then what happened, I am going to be keeping one cylindrical rod or maybe the sphere I am going to be keeping in this case. So then what will happen in this case? If I am going to be removing the support, so then what kind of actions it's going to be generating? So there I have removed the support, then automatically that object is going to be moving in the downward directions because of the self weight of the system. So then it is not maintaining the same position, but it is going to the downward directions. That means it is not in the equilibrium condition. So then we need to bring that body in the equilibrium conditions, because always the self weight or the gravitational force is acting on that member. So then what will happen, I remove that support, then I am showing with the reaction forces. This is the RA force is going to be generating from the frictionless support in the upward direction, that is going to be in the opposite direction. But in this case the weight of that sphere, that is equal to the reaction force what is generating from the horizontal surface. At the same time, if you want to keep these bodies in the equilibrium conditions, they must be existed in the same direction. So that means they must be in the same line of actions. So then W is equal to RA. So here I am going to be taking another example, a rod resting inside a sphere. So then what will happen, we need to assume the sphere is going to be hollow in shape. That means external diameter, internal diameter it has. So then what will happen in this case, I have taken the one sphere and a rod is going to be inserted inside that hollow sphere. So that means that rod is going to be making a contact with the two positions. First contact is going to be the A and second contact is going to be the B. So then what will happen in this case, that's going to be the self weight is going to be always acting in the downward direction. If I am going to remove the sphere, automatically the rod AB is going to be fall from that position. It will not able to maintain the equilibrium condition. If you want to maintain the equilibrium position at the rest condition, so then what we want to do? So in this case I am going to be show the weight acting in the downward direction. So then the reaction forces are going to be generating towards that side. Already we have talked about the equations of equilibrium or equilibrium of a particle. So then what will happen in this case, the three forces are going to be acting, then they must be passed through the same point of application. Then we can say that body is going to be in the equilibrium position. So here I have taken another example, that's going to be the roller and knife edge supporters. In this case, most of the time these are going to be widely applicable for the civil structures like bridges. They do have this kind of rollers as well as the knife edge supports. So then how it is going to be, the roller and the knife edge, they restrict the motion normally to the surface of the beam AB. So here I have taken the beam AB, one end is going to be the A, another end is going to be the B. So then here we can say one end I am going to be kept the roller support, another end I kept the knife edge supports. Then if I am going to be remove the A and B, then what will happen, the beam AB is going to be freely fall from the positions already we have seen in the early slides. So then in this case what will happen, so then the force is going to be acting. So then the force is going to be acting the P, then what will happen, if I am going to be remove the A, that's what is it is going to be restricting the motion, only the normal. That means vertically downward motions are restricted. Then the reaction forces are going to be generating in the same direction. So that's going to be here the RA force is going to be acting in the vertical directions because it restricted the vertically downward motions. And the knife edge follower also is going to be here, the restricted the downward motion. That's why the reaction forces are coming in the same directions. So then in this case what will happen, the P is going to be the load acting and RA and RB are the reaction forces from the supports. Then the three forces are in the equilibrium condition. So this is the what I was explained here. So then next one is going to be the hinged support. What is the hinged support in this case? In the previous cases we have taken the roller as well as the knife edge supports, but in this case we are trying to take the hinged support. So in this case what will happen, one side, one end of the beam AB I am going to be hinging. That means I am going to be pinning for that position. So then in this case AB is going to be the beam. Next, and I was hinged with the one special devices, and they are going to be inserted with the bolts. I made it that has a hinge. So in this case what will happen, so then other end I am going to be keeping the roller support. So then now you tell me the hinged support at A, what kind of motions it is going to be restricted. That depends on the what type of forces are acting on that member. In this case the P force is not acting in the horizontal direction, not acting in the vertical direction. So then what will happen, it is going to be the inclined direction. If I am going to resolve these forces, it will take in the horizontal component as well as the vertical component. The vertical components are always trying to move the body in the downward direction. At the same time, the horizontal force is going to be trying to move it towards the left side of this one. So that means the end A is going to be restricting the two types of motions. So then what will happen here, the two reaction forces are going to be generating. That I am going to be show graphically here. That same thing I have taken in this case. So one is going to be because of the vertical component of the P, YA force is going to be, that is the vertical reaction force component I have shown here. And similarly there is a x component force, that means the force in the x direction also because of this force P. Then there is a reaction forces I have shown because these two forces, this is going to be the x component force and y component, two forces are acting at the same point, then we can say there is a resultant component is going to be generating over there. So that is unknown in direction we have shown that. And next one is going to be the reaction force is going to be generating at B, that is vertically upward direction, because at B only the motion is restricted in the vertically downward direction. So then this is the force P, because we do have the two components, because of these two components of the x component and the y component of the P, then the two reaction forces are generating at A because it is restricting that motion. So that we have discussed here. And if the end A of the beam AB is embedded in the concrete. So in this case what will happen, the next support is going to be the built-in support. In this case, the first case we have taken the roller support and the knife edge support. The next one we do have taken the hinge support and the roller support. In the third one we are showing, see, that is the fourth one here, one end of the beam AB I am going to be inserting in the wall. So then what will happen in this case and what kind of motions it is going to be restricting. So there we can see graphically, this is the A as well as the B two ends, and the A is going to be inserted in the wall. So then there is going to be two forces are acting. One P1 is vertically downward direction and P2 is going to be towards the right side. So then it is very clear that already A is at the constraint. That means the we arrested there. So then what will happen, these the reaction forces because of the P1 and P2 also developed at the reaction at A. So that we can see here, this is the beam we have taken. When there is a P2 force is going to be acting, then automatically the same reaction force in the same line of action it is going to be generating, that is going to be the x component it is generating. And similarly P2 force is going to be acting, and then there is a component force is going to be acting, that is the vertically upward direction, because the restrictions are going to be given at A, not at B. So then the reaction forces also going to be generating at A only. So then what will happen in this case, because of the P1, that load is going to be, because of the distance is going to be there is a moment arm is going to be existed between the P1 as well as the point A. So automatically there is a moment forces are going to be generating. That's why that reaction force we have shown, that is the MA here. The next one you can see the real-time applications here. So that I have shown here, the man with the different chains are going to be constrained here. That is going to be, I am going to show there is a mental constraints are going to be generating. And the next diagram there is a glider as well as the sliders are going to be there within that system. So this is the widely applicable, this application for the windows they are going to be generating. So then what will happen, we are giving the constraints in terms of the guideways, and automatically the slides are going to be moving in the direction that is going to be helpful to open or closing of the window. So next one we do have a mechanical workshop. There is a shaper machine is there. At the above there is a tool which is going to be called the ram. That ram is going to be trying to move in the forward direction as well as the backward direction in the cutting motion. So then what will happen? There is moving in the guideways. That means we are restricting the motion, the free motion of your body, and we are trying to move in this direction. Then automatically the reaction forces are going to be generating which direction you arrested the motion. So next we can see there is a railway tracks and the railway is there. The rails are going to be moving on the railway tracks in this case. Then what will happen? These are moving in the constrained fashion. So then we are giving the restrictions to the free motion of your body, and we are trying to make to move in this particular direction, so that the specified function or the desired performance we can get it from the respective device of the engineering components. So what is our outcome from this discussion? We are able to understand what is the different types of the supports. So here the supports we are providing to restrict the free motion of a body. So that means we are giving the constraints to that body, so that the body can take the load or the power transmission, everything is going to be taking place. What is the frictionless support? Already we have discussed. When there is a frictionless support, a body is going to be contacting, then there is a normal reaction forces are going to be generating to the contact point. And roller and knife edge supporters we are going to be see. This is the widely applicable for the bridges, where they are going to be expansion also going to be taking place, and that reactions are going to be generating because of the free restrictions of the motion. Next one, the hinged support we are giving. In this case, at the end A hinge, there is going to be two types of motions are going to be generating that was arrested. That's why two reactions forces are going to be generating. In this case, built-in support also. In this case, what will happen? That depends on the type of the load, and we are getting the three types of reactions are generating in the X component, Y component, as well as the moments also going to be generating in that case. And what next one? What is the action? What is the reaction forces? We have seen that. So thank you.